Let's begin. Today's September 9th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 4, 5, 9, 14, 17, and 19. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our middle digit, the square digit, and compares it to the number 4. So should square be less than 4? Should it be equal to 4? Or should square be greater than 4? Criteria card B looks at our first digit, the triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card C will look at the 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card D will look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest digit. Should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card E again looks at our 3-digit solution, except this time it'll let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2? Maybe even all 3 are even. And finally, criteria card F will look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 6 criteria cards that we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is a little bit about that first digit. So let's go ahead and test criteria card B. Okay, so the Turing Machine does not approve of my choice. I did pick an odd 3. Since the Turing Machine does not approve, it's letting me know that triangle should be an even digit. So let's go ahead and type that up in our notes. And so again, the Turing Machine has informed us that triangle is an even digit. And of course, since it is even, we can cross out all of the odds. So let's go ahead and cross out 1, 3, and 5. So now, let's see, what can we test next? It's always interesting to see criteria card C and E, where we have an odd versus even. And it's always that relationship that always seems to be interesting to me. But I think right now, I think I'm going to test criteria card F. Okay, so the Turing Machine does not approve of what I have. So remember, criteria card F is looking at our first 2 digits and adding them up. So if I add up 3 and 1, that gives me 4. 4 is less than 6, but the Turing Machine does not approve of that. So basically, triangle and square should add up to either 6 or something greater than 6. So let's go ahead and type that up in our notes in section F. And again, that's that triangle plus square should either be equal to 6. Let me fix this. Should equal to 6 or be greater than 6. And so that really, I don't think that helps us to eliminate any possibilities. Well, no, I take that back, because the greatest triangle could be is 4. That means square cannot be a 1, because The largest sum that would include 1 would be a 5, and that is less than 6, which we don't, which cannot happen. But, 4 and 2 does give us 6. And unfortunately, we can't cross out the 2 because, again, we could add it to 4 or 5, even though it fails for 2 and 3 for square. So we still need to keep triangle 2 there. Okay. Well, again, the sum of triangle and square could be 6. So I'm wondering if we're dealing with 2 evens. But unfortunately, I only have 1 even in my proposal. So what would happen? We already know that we have at least 1 even. So let's see. Yeah, maybe let's consider that. So we know there can't be 0 since we've already established triangle to be even. Could we have 3 evens? Well, we can't have 3 evens because if we had 3 evens, we know there'd be 0 3s, and therefore making this card irrelevant, which we can't. And so, so it becomes basically a 50-50 whether there's a single 1, which I do have in my proposal, versus the only other alternative that there'd be 2 of them. So, let's go ahead and test criteria card E. Okay, so the Turing Machine does not approve of my single even, and so yes, I believe we can deduce that there should be actually 2 evens. So let's go ahead and type that up in our notes. And we are deducing because we haven't tested and confirmed that there are 2, but I think it's safe to say that yes, the solution has 2 evens. And again, just to review, we know it can't be 0 since we know triangle is even. We know there can't be 3 because that would mean criteria card C would be irrelevant. And since it disapproved of my single, the only last alternative is, yes, there are 2 evens. Now, we don't know which of the square or circle are even, but at least we know that we're dealing with 2 evens and an odd. And so let's see, we did complete our 3 Turing tests for this round. So now we're going into the phase where we'll discuss how to construct a good second round proposal. So notice we didn't test criteria card A, comparing squared to the number 4. And we did not test how many 3s there are, nor criteria card D, which tells us which one is the absolute smallest. So, and of course, for criteria card F, we haven't really pinpointed whether it's equal to 6 or greater than 6. So the good thing about that is that since we know there's an even, one more even in addition to triangle, sometimes when we have 2 evens, triangle and square, when added together, can give us a 6. Now, we don't know, I don't think there's anything here so far that says that they are indeed unique evens, right? It could be a double even, 2, 2, 4, 4, among the 3 digits. But we could try to create a proposal that have the first 2 add to 6. And it could be that square is 4, and if the sum is indeed 6, then that would mean that triangle would have to be 2, and we could have the odd, maybe perhaps not be a 3, and perhaps circle might be the smallest, so it would be forced to be a 1. That's possible. Let's see. But if that were the case, then why would we need, if we know there's an odd, and we knew that circle was the smallest, then I think it would be obvious that it'd be a 1. So perhaps maybe it's not a sum of 6. So that would mean it would have to be something bigger. And let's see. So there are plenty of combinations. Basically, square would have to be 3, 4, 5, and triangle would be forced to be a 4. So perhaps, but how would, we could say maybe square could be larger than 4, making it the 5. But if that were the case, then how would you pick between 2 and 4? Yeah, that wouldn't work. Let's see. I don't know, or perhaps maybe they're 2 evens, but maybe they're both 4, potentially. Yeah, because that's the only way. If square were 4 and the sum were greater than 6, that would force triangle to be 4. And then, well, circle would have to be the smallest, and maybe it'd be the 3. So it could be something like 4, 4, 3. Or actually, circle is the smallest, and it's not a 3. Maybe it's 4, 4, 1. Yeah, let's go ahead and try that. Let's see if it's 4, 4, 1. That'll be interesting. Okay, so let's see. What can we test? I feel like we almost have to retest criteria card F. Let's see. Could we do it in 3 turns? Let's see. If there are no 3s, that really doesn't tell us much about triangle and square. Let's see. Well, let's go ahead and test criteria card. Well, let's go ahead and test the criteria card F and confirm what the sum might be. Okay, yeah, so the sum is indeed greater than 6. So let's go ahead and update our notes. Okay, and if it is greater than 6, then we know square cannot be a 2, because 2 plus 4 is 6, and obviously it's got to be greater than 6. But everything else does work. Even the 2 added to 5 does give us a 7, and 3 added to 4 does give us a 7. So yeah, there are plenty of alternatives. I guess, let's see. Well, at this point, square can be anything. It can be 3, 4, or 5. So, wow. Well, let's see. I guess, yeah, let's go ahead and test criteria card A, and let's hope for the best. Okay, yes, so we got, I think, a bit lucky there, and yeah, so the Turing Machine has confirmed that square is actually equal to 4. So let's type that up. And since it is equal to 4, let's go ahead and cross out the 3 and the 5. Oh, and since it is a 4, it has, triangle has to be 4 as well, because 4 plus 2 is 6, and we already know that that can't be true. So yeah, okay, fantastic. And then, well, we know, actually, we don't have to test criteria card D for the following reason. We know circle has to default to be the smallest because whenever you have a scenario where you have a pair of equal digits, the either smallest or largest, smallest in this case, always has to be the non-pair. So yeah, we know it's the smallest, so great for that. The question is now, is it a 3 or a 1? And so at this point, it really is a 50-50. It could be a 3, it could be a 1. We know it can't be 2 because that would mean that there'd be 3 evens. So yeah, let's go ahead and test criteria card C. Okay, and the Turing Machine approves of the fact that there are no 3s. So let's go ahead and type that up, and that was for C. So we'll just say that the solution has no 3-digit. Okay, and so and let's also type in that we'll deduce that circle is the smallest for the fact that, or how I described it earlier, that the non-pair has to be either the smallest or largest, in this case smallest. And so that would mean that since there are no 3s, yeah, the smallest odd digit is a 1. So let's go ahead and cross out everything else. And so it looks like the solution, yeah, is 441. Let's go ahead and type that up. Oops. Uh-oh. Let's see if I can fix this. Seems to be a bit of a lag. 441. Okay, well, let's go and confirm. All right, so we're proposing that the solution is 441. Oh, fantastic. Okay, well, let's see how we did versus a Turing machine. Well, I think our 2 deductions really helped out. Notice that we did test, we did 6 tests out of 6 criteria cards, but we actually deduced one of them outright, criteria card D. So let's see, we did do B, E, F in the first round, got them all wrong, and then did A, C, and F again. We skipped D, and we got all of them correct. So let's go ahead and type that up. So BEF. So BEF. We're all incorrect. And then we did AC, skipped D, and retested F. And they were all correct. Wow, fantastic. So we solved it in 6 questions where the Turing machine took 8 questions in 3 rounds. Well, that was great. Yeah, I think what really helped out was obviously the initial deduction that there are 2 evens, and the fact that when we tested the criteria cards in round 2, we were able to deduce that yes, circle was the smallest. So those 2 really helped out. Well, what do you think? How did you solve it? Did you notice anything? Add your ideas to the comments. If you like the video, please give it a thumbs up so that more people can find this channel. And of course, hit subscribe to be notified of any future videos. Well, until next time, have a great one.